they kind of forcing things. So yeah, welcome to today's tutorial. We'll be doing a past paper. I didn't decide which past paper we're going to do, so we're gonna look at the past papers together. So let me see, 2018. Snatem. Yeah, the one who's not muted, yeah. I feel like I must. Where, where's this thing? Minimize. Okay, so I don't know why you guys are in a rush for question papers. I don't know. And to be honest, you will realize that it's gonna be the exact same thing as just doing Java first, because I'm gonna have to explain that thing before I apply it. So let's check here. Result type, blah, 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 blah. Create an interface, iRenderer, visitor design pattern. Oh, this one is JavaFX, but this is cool. Yeah, this is nice. This is not bad to do. Fatal, barren. Damn, that's not a right example for the semester test. But sorting. They are the lecturers again. So let me look at 2020 provided files. Oh, this was a mock test. Okay. Which is basically another past paper. Yeah. So it was the 2020 past paper, but it was a mock. Basically, the practical you guys are going to be doing tomorrow. It was similar to this. Collider, next, blah, blah, blah. Yeah, it's basically the same thing. Same shit. Nothing has changed. Then you're going to have this, but we're not going to do the JavaFX question because I'm not sure. The thing is, I'm confused. Some students are telling me JavaFX is there. Some are telling me it's not there. So I'll just not cover it until you guys are able to kind of agree. All of you guys agree with each other on one thing. Is JavaFX there or is it not there? Yeah, you can unmute and speak. The one who raised this his hand, Moses. H file. Yeah, I can hear you.
The VFX is not there, but there will be question 3. I don't know. That question related to generic or
No, so they said it's not there.
yeah, but there will be question 3.
Yeah, I didn't catch that. But I just understood the part that is not there. So that's fine. We're not gonna touch it. So let's start to the question paper then. So question one, I think question one, most of the things you're gonna create yourself. That's why it didn't come with any extra. Hey, 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 hey. UML. Like my question is, how did they expect you to finish within the allocated time? I know it's quite a lot of time. Okay, this was Java, the JavaFX, but still, there's quite a lot of things to do. You have to do UML again. Let me see. Does it UML here? Okay, second question doesn't have UML. So it's only the first question. But still, they want you to be opening diagrams here, drawing there, putting. Yeah, nah. If you're a slow learner, it's gonna go down for you. So let me create the project, right? So Eclipse, if you're a slow learner and you're a slow type, no, this is not what I wanted. I want to see the batch file. So the batch file, right? It's basically the same batch file that you guys have been getting for your practicals. Let me double check something here. Cleans. Oh, it has no Java effects. Oh, okay, I see. Yeah, so so this one is no Java effects because question one is no Java effects. So we don't need to do anything related to that. So I'm just gonna open this inside my inside my Eclipse IDE, right? So we are doing this. So I'm gonna double click this and I put it to the side here. Yeah, can I do that? Why is this thing giving me a hard time? I don't know. So let me close this project, chapter 79, close project. Then I'm gonna go to file. When all of you guys are gonna get additional files. So you must work with the additional files that you're given. What I advise you to do, first step, because trust me, if you do spiritual things, it's not gonna end well. Your code is not gonna run. And that's how annoying this thing is. So before you do anything, before you even go to your project, right? Go to your folder, the first folder, right? You see it's written Q1, meaning that's the additional file or the folder you must open inside Eclipse to answer question one, only question one. Don't be doing your own spiritual things and putting it in one. I'm telling you, it's not gonna end well. They have zero tolerance for bullshit in the test venues. Trust me, it's not gonna end well. They have no sympathy. You can cry and say, look, like, try again next year. We'll see you. Usually it's not going anywhere. There's no floods that are gonna come here. Don't worry about it. UJ is still standing. It's still there. You'll find it again next year. So you're gonna have to rename here. You put in your initials. I'm just gonna say SI, just random values, right? So yeah. You see, you've renamed your project, right? So you put in your credentials, your details, right? Now you can go inside Eclipse and open the project. Because I think I once experimented with this. If you do it vice versa, you start by opening the project, then you rename. Sometimes it doesn't work. I don't know. The thing is, it's always unpredictable behavior. So you need to start by renaming it before you import it into your project. Then you're gonna go to File on the top left corner. Then you click on Open Projects from File System. From file system, they mean from your file explorer. That's simply what it means. So you click that option, then you're gonna choose directory. Directory is a synonym for folder. So I want the folder. Isn't this a folder? Yes, it is. So I want the folder. So I'm gonna click on directory, go to where that additional files are saved. Messages to no, I forgot. Is it 2020? 2020, right? Yeah. 2020, then here. Don't do spiritual things. Don't go inside here and choose things like source SRC folder. You're on your own, chief. That test, there's no Makhelwane will not help you. You're on your own. I guess some of you are attending the session to cram. Good luck with that. It's not gonna end well, and I hope it doesn't end well. So that you learn your lesson. So I'm gonna click this folder, click select folder, then make sure this part, right? You see this part over here. If you leave it unselected, but then by default it should select it. I don't know. The thing is sometimes the computer labs, they have old Eclipse, like a very old Eclipse, and things tend to crash. So if you you don't select this option here, make sure this is ticked so that it imports everything. If you don't, good luck with that. That's all I'm gonna say. Good luck with whatever you wanna try. You're choosing the wrong time to be spiritual. You can't be spiritual in the test venue, but this is what I also do not like. You see, we have another problem here. This is not actually yeah, it's not actually a Eclipse project. Sometimes they give you an actual project, sometimes it's not. It's kind of tricky to know. So if you look at this one, it has lib, yeah, okay, I'm gonna teach you a different way because if you do it the way that I'll just show you right now, it's not gonna work. So yeah, I don't know why they did that. So let me delete this. Nah, I don't want to delete it in my. Yeah, don't select this. Don't select this option. If you select this option, it's also going to delete it in your operating system. So I'm going to click OK. Let's just create a new project. Yeah, just this is the best way to go about it because it seems like they have a lot of politics, these guys. Then it's CSC 0282 ST2, right? I'm just naming it the way I feel like naming it. Or did they name it? CSC2A. CSC2A underscore PT and then Q1, right? Yeah, PT Q1 underscore Q1. So this will be the first thing. And in terms of when you're working with computer labs, right, you need to be very careful. Don't be saving things in the default folder, especially if you're creating the project yourself. As you can see, we are forced to actually create the project ourselves because the lecturer has decided to just give you folders, not actual Eclipse project. It's actually just folders. So we need to create an actual Eclipse project, even though it doesn't actually matter. To be honest, you can open Notepad++ and write if you're the GOAT. This is for those who practice Java and to follow my instructions. They read the textbook, they've attended every single class, or they've watched every single recording that we've ever had. They've done practice questions. Some they've even finished the whole questions on that website. There's people that are serious. So if you are like that, you're allowed, to be honest, to use anything. You can use VS Code. If you don't know, that means you don't practice enough. The person who practice, they should know VS Code. You can use VS Code or Notepad++, anything. You don't have to use Eclipse because it needs to run with a batch file. So that's the main important thing. Eclipse is for, if you don't know Java, it to tell you a lot of stuff like auto completion, things like that. So make sure you unselect default location, then you click browse. Then you save it on the T drive. T drive is basically it has a T and a colon like this and a forward slash. It's going to be like that. That will be the T drive. But in my case, I'm just going to save it in the default location. That's fine. Then make sure you unselect module info.java. You see this part over here? Everything is not going to run. I don't care how many assistants you call to ask for your help, for their help. They're not going to help you. They might not even know what's the issue because they were not there when you're creating the project. So make sure that's unselected, click next, then click finish. I want you to notice something different here. Remember that folder that I added, it didn't have the JRE system thing, meaning it was an actual Eclipse project. So that's why I had to create an Eclipse project separately. Then after I've created the project, I go into my Q1 additional files. Then I click this, and then I copy, right? Copy that folder, go back to Eclipse, select the main project name, right click on then right click on the project name. Then I'm gonna click paste. Then there's my docs, right? I've seen students can be very spiritual. Students, I think you guys should, I don't know, go become monks or something. You guys are very spiritual. You see students trying to run a batch file in Eclipse. I don't know why you want to do that. I don't know how many screws you have loose. Why would you want to run a batch file in a Eclipse? No, man. Some things they shouldn't be tolerated. Why would you be running batch file in Eclipse? Batch file is run inside the folder, inside the operating system, not Eclipse. Eclipse is for Java, writing Java. But batch file is not Java. Does a batch file end in a .java? Nope. So why are you trying to run it inside Eclipse? Hey, students will shock you, Shem. So yeah, we have this. Then now I can add my classes, right? Before I do that, let me go to my question. So problem statement, if I can try, yeah, we have up until 10 p.m. So if I can try to finish question one, then tomorrow question two, then another day, other question papers. Yeah, we should have a lot of practice. But at the end of the day, if you don't practice, you're not gonna go with my brain in the venue. You should go practice all these question papers, redo all of them, do the homework that I'm gonna give you. So today your homework will be to redo question one without looking at slides, without using ChatGPT. If you cannot do that, go read the textbook. That's what by practice it means not looking at the slides. That's what practice means. No slides. Because you won't have slides when you're attending that venue. So the problem statement, the Utopian Sciences Board USB. is designing a system to store and report on information about photon colliders. Well, the physics students don't they know what a photon is. I don't have any clue what that is. So a photon collider is an abstract base class that stores a photon amount, a random integer between, and provides a report like operation. There are two kinds of photon collider. Basic, blah, blah, performs a collider is an array list. This is too easy. Yeah, this is way too easy. I can literally give myself tops 30 minutes to do this question because the 30 minutes will be wasted on reading. If I could just simply scan the question and it's in my brain, maybe 10 minutes tops. This is easy. This was easy. And this was a COVID paper. This was easy. I think maybe it goes down when you go to Java. Yeah. Yeah, it goes down there. Yeah. I knew somewhere, somehow it was gonna go down, but this was easy. Even regular expression, this is all easy. But question one is always easy. I will need you guys to make sure you get total of question one. I don't want no excuses. It's not about you being dumb, being smart. It's about you just going to start. That's all. Just go read the textbook. Go if you once you're done reading the textbook, if you want a summary, you can look at the slides. But you shouldn't need a summary if you've read the textbook. So yeah, you have a lot of reading to do. So the photon collider is an abstract class. So let's start with photon collider. So before we get into main, okay, before I do that, right, it's you guys will have enough time to read everything. Me, I don't have that luxury. I'm just gonna scroll down and look at packaging. Did they mention packaging? They didn't talk about packaging. I don't see it. Let me look carefully. Packaging, instructions, blah blah blah, blah blah blah, blah blah blah, blah blah blah, blah blah blah. Yeah, there's no packaging here. I don't see it. It's not mentioned in the question. Yeah, I guess it wasn't important. Yeah, if it's not mentioned, don't put it. If you want to put it, that's up to you. Um, you could put it and have axi.csc dot what thingy. That's up to you. Maybe you're gonna call it dot csc2a dot classes, maybe, but you don't have to. So I'm gonna create my main class first. So class main. Hey, this was they were too lenient in this question paper. If they're all this, if they're the same, then you guys should get 100 because it's not JavaFX. Everyone should get 100%. It's possible. I have people that I've taught only within a week, and the person mastered everything and managed to go pass because they listened to what I said. And they also started reading the textbook a bit. And then they realized, wow, textbook helps. So if you don't listen to me, yeah, it's not going to end well. The students, trust me, the students who are in your class right now who didn't listen to me. Photon collider, so copy that name. Yeah, I'm personally not going to put packages. You can put packages if you want because it's optional. It's not mandatory. There's no marks for it. So I'm going to create a photon collider, right? And it's up to you. See, that's the nice thing about Eclipse. There's a lot of options. You know that you can type less. Like you can finish this thing in 5 minutes. In question one, you can finish it in 5 minutes if you doing the shortcuts. For example, you see all the options here. You can make the class public or package or private or whatever. And you can also make the class abstract by clicking abstract. You can also make it sealed or final. You can also specify its superclass that it extends. So you see, there's quite a lot of options in Eclipse that you can help you to avoid typing. But we're going to type, so I'm just going to leave it like that. So collider. So we have a photon collider. They said it's an abstract base class, right? This abstract base class, most of the time, right? It's not always the case, but most of the time, an abstract class is only abstract if it has something that's abstract. Abstract meaning that it's incomplete. There's no implementation for that thing. Mainly functions, right? So whoever unmuted, who's that now? Someone's unmuted here. Okay, so as I was saying, abstract classes, right? Abstract classes usually make a class abstract By the word abstract, it means it's incomplete, meaning the class is incomplete. Imagine you see people, you're always passing by they're building some building, right? Or a rest or an accommodation or something. And they're not done yet. So we would say that that's an abstract building, meaning it's an incomplete building. There's some floors that are missing, there's windows that are missing. You wouldn't move into it, right? Unless if you have a sane person. Yeah, you wouldn't move into it. But if you're insane, then you would. But why would you want to do that? Because it's an incomplete structure, right? It's an incomplete building. So that's what abstract means. Putting that keyword right next to the class, that's literally what it tells Java. That's why there's this rule that if you have an abstract class, you cannot create an instance of that class. Basically, it's like you're trying to move into incomplete res, which is you're gonna move into a room and there's no door. There's no door for the kitchen, there's no door for the room, there's no door for the shower. And you confidently gonna move into that res. You must have a few screw loose, right? So you wouldn't move into it. So that's why since you cannot, it's an incomplete thing. You cannot tell Java to build an instance of it because it's incomplete. It's abstract. So if you try using the new keyword, you will see it's gonna crash. So let's make the class abstract. So the keyword abstract, you're gonna put it right before the class keyword. You could specify, you remember when we're creating the class, you could choose that option for abstract to make the class abstract. That's up to you. So this is my class. It's going to store a photon amount, right? The photon amount is going to be a random integer. They said a random integer, right? So it's going to be a random integer, but then we're going to need to declare it first before we initialize it. So I'm going to say private int. I'm going to call it photon amount, right? If you read the textbook, it will tell you why this is important to name your variables in full. And then it provides a report micro black hole operation. So copy this report micro what operation. So by operation, right, they mean function, they mean method. So I'm gonna have public. So I'm gonna have public. For now, I don't know. Let me double check what it returns. Let's see. Yeah. So do you explain it here, what it does? So it does the operation differently. It prints its photon, it prints, you see, printing. They never mentioned returning anything. So if the function, all it does is print, it's just simply printing to the standard output stream. So there's no need for me to return anything. So that means it's going to be void. So void report black hole, report micro black hole. But there's something that's missing, right? You might be like, okay, let me implement this function, but the question is, what implementation are you going to put? That's the question, right? Because if you read the question paper, it says that this report micro black hole operation, it's done differently based on the derived classes. Since it's done differently, that means that it's going to be different, right? The base class, remember the base class, its main goal is to store things that are common. Is there anything that's common? None. Because this one totally does it differently, divided by 10. This one includes acceleration, totally different. So then unrelated. So there's no common thing. That means there's no implementation for me that I can possibly put there. That's where we have to do things that we call abstract functions, right? Abstract methods. Basically, it's a method with no implementation. So you're going to say public abstract void report micro black hole, right? Because you don't know what to write. So you leave the implementation of the function to the derived classes. That's what it means when you make a method abstract. It means that me as the parent, I'm not going to implement anything. This is basically, you can think of this as like generational cases, right? Your parents would be like, nah, fam, I'm not going to break generational cases. I'm going to leave it to my kids. they'll break the generational cases. I trust them. Then they pass them down to you. They're like, yeah, you must deal with everything. So it's sort of like that. They're deciding to neglect, the parent is deciding to neglect what they're supposed to do, which is the responsibility in a way, right? Then they're gonna say, nah, my kids will do it. I'll wait until I give birth to a child. Then the child will take over. They'll do it. That's literally what you're telling Java right now over here. That's why if you try to do something like this, he's gonna be like, "What do you mean, bruv? Like, do you understand Java at all?" That's basically what he's trying to say here. Do you even understand what you're doing? Because the word abstract means that it is no implementation. So what the hell is this now? So that's why I just simply put a semicolon there. By default, if your class is an abstract method, meaning an incomplete method, because this method has no implementation, that means the class is incomplete. Basically, it's an incomplete structure. It's like, for example, a building with no doors or no windows is still in construction. So that means the building itself will be abstract, will be incomplete, right? For example, if you have a building that's being built, right? And people are not done, the builders are not done building it. There's some windows that are not installed yet. There's doors that are not installed yet. Those doors that are not installed, right? That means that they are missing. That means the whole thing becomes incomplete. That means we cannot allow students to move in yet because we're not done building the full thing. So that's why if you have an abstract method, it forces the class itself to be also abstract because it contains something that's incomplete, which would mean that the class as a whole, it's incomplete or it's abstract. Yeah, I explained extensively there. I'm not gonna explain that next time. So this session, this paper, right? That's where I'm gonna explain extensively, thing one thing at a time, like inheritance, things that we haven't covered yet in our intensive revision. But then the paper after this, I'm not gonna explain anything. I'll just answer the question. And then you see, I'm sure you can notice a difference in the time. You might actually be able to finish every paper within the 2 hours because of how much less explaining I have to do. So we have this, right? So we are done with the abstract class. The random generating part, we'll figure that out later, right? We're gonna figure that out later. I wanna see whether anything about it, should it be inside this class or, yeah, it's fine. We can generate it. So let me create a constructor for this. Since this is an abstract class, right? To be honest, this will be the 100% right way to do things, right? 100% right way to do things. Because this is an abstract class, that means we'll never do something like new because you can't create a new photon collider because it's abstract. It's incomplete. You can't say, okay, this the accommodation is now ready to accommodate students, whereby it's incomplete. You can't do that. You can even get sued and lose accreditation, right? That means you're no longer accredited. That you can lose that paper. So that's why if you try to use a new to create a collider, a photon collider, it's not gonna work. So that's why I'm gonna make my constructors protected because they're mainly gonna be used by the children. Because if you have an abstract class, right? Remember we talked about an abstract class. You are saying that I depend on my descendants or my derived classes to provide the full complete implementation. That's what it means. So here I'm gonna provide a protected photon collider. I'm going to create a parameterless construct, right? Because I don't need to actually pass a parameter because I'm not getting this value from the user. If you read your document, right? They said it's a random integer between 10,000 and 255,000. So it's a random value. So I can just simply create a parameterless constructor, which generates the random value. Because remember, the base class stores common information between all the classes. So therefore, I need to do it once inside the base class, not to repeat it in the derived classes. Remember, we're trying to not to repeat ourselves because programmers are what? Are lazy. So let's generate a random number. To generate a random number, right, you need to instantiate an instance of the random class. So random, I'm going to call it rand is equals to new random. And then here usually pass in the seed value. If you still remember in C++, I think, yeah, this was the srand function, right? Then time, blah, blah, blah. If you still remember all those things, similar to C++, but different syntax. Here you can pass the seed value, but we can leave it as it is and use what is this? To be honest, this is actually not random. It's called pseudo-random, meaning it mimics a random number, but it's not entirely random, meaning hackers can predict that random number once they found the formula because it just keeps on repeating based on one formula. There's another class, I think it's, let me try to remember. I was reading this. I think it's called secure. Is it secure random? Yeah, it's called secure random. That's the one whereby it generates an actual random numbers, right? But pseudo random numbers, it's fine. We're not building an app for Mark Zuckerberg here. It's fine. Even if the hackers can hack it, it's fine. We're not gonna worry about the security of the app. So we're just gonna mimic a random number, not necessarily random, just mimic. So by mimicking, we call that pseudo, right? Pseudo random number, right? Meaning it's like a random number, but it's not entirely random. Meaning you can predict it when you know the formula. Basically, you can find the seed, which is that's basically the formula, the seed value that was used. So let's generate a random number. To generate a random number, right? In the random class, when you for every instance of the random class, you can call next methods, right? So next int, next short, next bool. I think there should be next boolean. Yeah, a random boolean, either false or true, random. So there's a lot of just if you remember scanners, right? It's like a scanner object. Works entirely the same. So there's I would say there's two ways to create the random integer, right? Remember, we're gonna store the random integer inside photon amount. So photon amount is equals to rand dot next int. So okay, there's three. There's the one whereby it generates any random integer. It can be a very big number, even 4 trillion, like any number, but that's not what you want. You want the one whereby we can specify the bounds, which is the ranges, right? So if you read the documentation, that's what I like about Java. Java, I don't understand why people fail because you have all, do you know that you actually have all the code and all the nodes to find all the functions you will ever need? There's the Java talk here. You can read everything there and understand. They're telling you here that the upper bound is exclusive, meaning that whatever value you put in there, it excludes that value. So that means if you want to include that value, you're always going to have to add +1 on the upper bound. The lower bound is indeed included. So that means if you want to generate a number between 0 and 10, right, Java will actually exclude the upper bound, which is this 10. That means it actually generate a number between 0 and 9. So if you want to force it to generate between a number between 0 and 10, you have to add 1 to the 10, so 11. So that's what I mean by adding a 1 to the upper bound. And you wouldn't know that if you didn't read the textbook. And I'm going to keep on wrapping it in until you read the textbook. So it's 10,000 to 255,000. So starting from 10,000, right? And for those who read the textbook, this is allowed. So 10,000, 250,000. So it is easy to read. So starting from 10,000 to 250,000. But this will be incorrect because it's going to exclude the 250,000. For you to include the 250,000, you need to add that one, that extra one. So it's going to be 250,001, right? So yeah, they didn't mention including, excluding. They didn't mention, but if they were very explicit and they mentioned it, you'd be in trouble. But they said between these numbers. I'm assuming it includes both bounds, upper bound and lower bound. So we've generated a random integer, and this random integer is generated when this constructor is invoked or called, right? As you can see. And then we are done with this class. Then you get your full marks there. Yeah, just Java doc. Yeah, so I'm gonna say this is my instance variables, right? And then this would be my abstract method. I don't have to put JavaDoc for that. So there's no need. So that's done. Like I said, this is easy. So telling me you can create this thing from your mind, just simple lines from your mind. You're in the wrong degree, Shem. I don't want to lie to you. I'm not gonna sugarcoat it. If you can't write these three simple things, you're in the wrong stream. Try accounting or something. So basic, there are two types of colliders, right? So we have two kinds of. I don't like how they're phrasing this thing, but yeah, you need to understand English. That's a you problem to them. That's how they view it. It's a you problem. So two kinds of. There's kinds of over here. It means two. It means inheritance, right? There's derived classes or sub classes. So the two subclasses we have is basic collider and experimental collider. So I'm gonna create the basic collider first and follow the instructions. They told you that basic collider has no additional attributes, meaning that it'll just simply implement the function in your base class. That's it. So it will have no other variables. That's basically what they're saying. So I'm gonna create another class here. So a new class basic collider. Like I said, you can avoid this whole thing of typing. Remember, we know that collider is a subclass. That means it is a superclass. There's a section for superclass over here. You can click on browse, then specify what is the superclass for this class you're about to create. Make sure you delete everything that's highlighted there. Then you type in the name of your superclass. There's the name over here, Photon Collider, right? There's the Photon Collider. Then you select it, then you click OK. Then it's gonna put in the keyword extends for you and all that stuff. I don't want to do that. You can do that for yourself, but I don't want to do that. So basic collider, yeah, there's no additional parameters, right? Done. Then I'm just gonna click generate comments. Let me put JavaDoc. It's actually kind of important. So I'm gonna say at author, basically who wrote this code. So text enemy, and then version is basically what the code is about, is based on. If it's based on a prac, you're going to specify the practical number. It's based on a semester test. So this semester test 2, the 2020 version, right? So I'm going to copy this JavaDoc so that I don't have to type again. Then here, paste it there. You need to put it in every single .java file. Every .java file. If there's 16 .java files, every Java file. Else you're going to lose the full marks for JavaDoc. So it has no additional attributes. So we need to tell Java that this is a subclass, basically a child of some parent. How do we tell Java that? We use the word extends, meaning that I'm going to extend based on what's based on my base class, which is true. For example, if you look at your family tree, right, in your family, you always extend it, right? The new generation always extended what the previous generation did. So, for example, if the previous generation they only managed to go to matric, the newer generation, right, managed to go to university to get now they're even getting PhDs, right? That means you've extended what the parent was able to do. So it's the same thing. So you're gonna just say extends to say that I'm extending. Sometimes you might extend, sometimes you might not extend. That's, there's the black sheep of the family, the one who doesn't care about anything. He doesn't do anything different from his parents. If his parents were abusive, he's gonna be abusive. Things like that. This is basically that person, this child class, because it has no additional things. So that means it's exactly like its parent. That's basically what it means. Because it is no additional, basically there's no unique traits about it. So extends photon collider, right? Then remember with that abstract method, and whenever you inherit from an abstract base class, right, and you have an abstract method, you are forced to implement that function, unless if you make maybe the abstract, the child class is also abstract, then it's not going to force you. You see, the error goes, if the class is also abstract, the error disappears. But then some point down the family tree, some point down the line, whether it's going to be and your parents' grandchild who's going to end up inheriting and doing the right thing, breaking the generational cases, all those things, someone has to do it. And so it's gonna fall onto someone. In this case, it's gonna fall onto this subclass, right? So we have to implement this function. So we're gonna talk about something that we call method overriding. So if you have this function over here, right? Let me copy it, and you put it inside of a child, inside of a subclass, right? Or make sure you remove the abstract because it's no longer abstract. You are now providing the implementation. So I'm going to remove abstract and then the error disappears, right? Because I'm following protocol. I'm doing the right thing. So there's the function, right? When you have in Java, when you have a function that is the exact same signature, right? Meaning you see it returns it's public or void, and it has the exact same name and exact same parameters. We call that overriding, meaning that you are overriding, you're taking over. It's like you're taking over this implementation, if there was any, and providing your own implementation. So yeah, it's like you're taking over. So you have to use something that we call annotation, which is the at override annotation. Above, you have to put it above the function, above the public keyword, just literally above it. This is what we call metadata, right? This is metadata, meaning that it's not important because you see that it works without this annotation. This annotation is just to help Java do some optimizations, and also for other people, other developers, when they're reading your code, they can understand better that, oh, this is an overridden method. This is overriding. Oh, okay, I understand. That means they don't have to go to the base class to understand overriding. They can just see this at override and then know, oh, this is a function that's already defined in the base class. So I'm going to leave it like that. So we understand extending, which is inheritance, right? Then we're going to create the other collider. So experimental collider. So there's one for experimentation. So that means we're going to have extra values, right? So I'm going to go here, then src folder, right click, new, class, paste, generate comments, do this. Then I'm going to copy the Java doc, then put it here like this. Then, yeah, we need to extend to tell Java that this is a subclass of photon collider. Basically, we're saying this is a photon collider. Then I'm just going to simply do auto completion. I'm not going to type. So you can go to that error, right? You see, I'm teaching you something here. You can go to the error at the top. That's why I don't understand why people students fail Java, to be honest. I don't understand. It's virtually impossible to fail it. Like, it's literally impossible, because you don't have to cram and remember everything. You can just simply test it out and check the error. What does the error say? Can I import and then import? But then don't just be importing everything. So the type of experimental must implement the abstract method, blah, blah. Then you tell Java, add that method. So I'm going to click add, and then boom, that's the method. So like I said, Java is nice. You can pass it. So I'm expecting 100% for question one. No excuses. Unless maybe you lose marks on UML. That's understandable. So we have experimental collider. It stores an acceleration index, which is another random thingy, a random float between 0 and 1. So it's a random float. They could have told you if it was a double. You see, they could have said if it was a double. So I'm going to use a float. They said float, not double. Even though double is technically a float, but it's a double precision float. They will tell you. They'll never make that mistake of not being clear with their words, with their wording. There's an acceleration index, so I need to create it here. So I need to put in some Java doc there, instance variables. Then I'm going to have private float acceleration index. You don't have to write it in full like that, but then I like to make sure that there's no ambiguity in my code, right? You can understand, but that's simply just reading the variable names. Each kind of photon collider performs the report black hole operation differently. This is what we'd call, if you remember, polymorphism. There's polymorphism here. So a basic collider prints the photon amount, right? So that means it takes the photon amount from the base class, divided by 10, and it prints it to the standard output stream. They didn't talk about rounding off and whatnot, all those things, but to be honest, it's quite important to do that. I'm going to round it off to 2 decimal places because I don't want my number to be too long, right? They didn't mention it. It's not a must. I mean, it's optional. It's up to you. So let's see. Yeah, let's start with basic collider, right? That's the one where it takes in the photon amount from the base class, which is, I've named it for photon amount. So we're going to use that variable. So I don't know why it's doing this. It's fine. So I'm going to go back to collider, then I'm going to print the standard output stream. Since I have a float or a floating point result, that means I'm going to have to, what is this? Rounding off, right? So there's many ways you can round off. You can use the round function from the math class. That's up to you. I like to use the printf method. Basically the percentage dot 2f technique. So I need to calculate what is it called? They didn't give it a name. Yeah, I'm just gonna calculate call it answer. I don't even know what to call it. Then I take the photon amount. So photon amount. And remember it's in poor design of poor UML design, right? The thing is they didn't mention a lot of things here. It's so vague, right? The attributes and operations. Yeah, it's so vague. They didn't talk about accessors and getters. They didn't talk about it. Yeah, they didn't even mention it. So what I'm going to do, right? The photo, you see the photon amount, it's not meant to be known by the user, right? So I won't make it private, but I'll make it protected so that each of the subclasses have access to the photon amount. So I have to go back to my base class and make that change. This is no longer private, this is protected. So protected, then now when I try to access it here and I do this, it should work, right? See, it now works because I made it protected, meaning it's public to all the people who are part of the family tree. Basically, all of my subclasses, all of my descendants. It's public to them, but it's private to anyone who's not part of that family tree or part of that lineage. So that's why it works. So I need to calculate the photon amount divided by 10, right? Mm, right, divided by 10. So I'm going to divide it by 10. And remember, we talked about the processor, right? The CPU. It only does arithmetic based on the same data type, and it returns the same data type based on the data type that was used. So if you're using two integers, right, it will give you back an integer. So that's why we have to make at least one of the operands to be a double or a float. In this case, you see photon amount is an integer, right? So this will do what we call integer division, which is going to return a quotient, which is not what we want. We want the full number. So there's many ways you can do it. Some people would like to complicate things and do spiritual things and cast here and say, yeah, float. That's okay, right? I'm not gonna judge, but I'm judging at the same time. There's no need for you to be doing all that casting because there's a literal here. You can just simply change this to be 0.0 like that. Then just say float because the thing is, right, if you leave it like this, you see, that's why it's important to read the textbook. I'm going to reiterate again. It's very important to read the textbook. All of these things, the little details, they ruin everything. Then you end up failing the whole semester test. So here in Java, right, when you create a literal, which is literally that value itself, 10.0, it treats it as a double, not a float. So now it's going to see this is a double. All of this is going to return a double. A float is 32 bits, right? And a double is 64 bits. So you're trying to store something that's too big in a container that's too small. So this is too big. So that's the problem. That's why it's complaining. So you have to tell Java to treat that constant as a float so that it's going to cast this automatically to a float. Then you get floating point division, right? Which means it's going to be the same size, 32 bits on both sides. That's why it stops complaining. Then I'm going to print it out, and then I'm going to use printf. Then I'm going to pass the variable here. Okay, it's called the answer, right? So that's a float. I want to display it in two decimal places, right? Prints its photon amount divided by 10. So the string that I'm going to use, right, I'm going to say photon amount divided by 10 is, right, put a colon there and then space to make it easy to read. Then %f to say that this will be a placeholder for some float that I'm going to pass, which is this float over here, right? Then that float over there, I want to round it off. So right before the f, right behind the f, I'm going to put a .2, which means that round it off to exactly 2 decimal places. And then I'm done. So I'm done with this class, basic collider. That's done. We don't have to worry about that anymore. That's implemented. It's done. And I can also put, I forgot to put an end of line character after printing. So you can simply put a \n like that. But I know Java, I read the textbook. So I'm going to use %n. So that's done. Then I can go to the experimental collider. Then this is the experimental collider. Experimental collider, it prints the photon amount multiplied by acceleration index. So this is a string that I'm going to print to the standard output string. And yeah, I remember there's a question. That's why sometimes to read is very important. You see what it did, right? It said in one subclass you should output the standard error string. Then for the other subclass, it said you should output the standard output string. Two different things. So be very careful of that. So it's the photon amount multiplied by the acceleration index. So I'm going to copy that, go back here. So it's just multiplied. So that means it's the result, right? It's multiplication. So it's probably going to give us, it's going to give us back a float. Excuse me. So another important thing that you need to realize here, right? There's another very important thing you need to realize. The experimental collider, right? We need a way to initialize the acceleration index, right? So they told us that it's a random float between 0 and 1. So let's create a constructor for that. So it's going to be public experimental collider. Since we're generating the number ourselves, we're not getting it from the user, so I'm not going to pass it as a parameter here because I'm not getting it from the user. I'm generating it myself. And I forgot to also create you also need to create constructors in the subclasses. Yeah, even if it does nothing, just simply call the base class. If you read the textbook, again, if you read the textbook, if you have a subclass and you're trying to call the constructor of the base class, it should be the first statement in that construct. So I'm going to say super, empty brackets like this, This calls my base classes constructor. So this call right over here, this part over here, it's very important because remember, we cannot create an instance of this. So I need to call this constructor so that it generates a random value. Basically, it initializes photon amount. That's why I say it is very important to create the constructors. Because if you don't create them, photon amount will not be initialized. So that's something that you need to understand, especially when it comes to inheritance. Always create constructors in the subclasses. In this case, right, acceleration index is a random value, so we're not getting it from the user, so therefore it's going to be a parameterless constructor. Remember, we need to call the base classes, the superclasses constructor, of which is parameterless, so there's no parameters here. And it should be the first statement in every constructor of the subclass. So now I've done that. I understood Java that that's the first statement. Then now I can initialize my acceleration index because this calls my base classes constructor so that it initializes the photon amount. Then now I'm gonna instantiate another random object, right? So that I can generate a random float. Then I'm gonna say acceleration index is equals to rand. Then we call a method from that object. So rand.next float. And then we have three types. We always have three types of functions for each data type. The parameterless one, the one with only the upper bound, then the one with the origin, which is the starting or the lower bound, and the float bound, which is the upper bound or the stopping point. So I'm gonna need the one with two parameters, right? Yeah, Java Eclipse kind of auto completes and puts variables for you there sometimes. So you don't need to do that. So you need to start from 0.0 up to 0. Up to you said up to 1, right? So up to 1.0. But remember we need to add let me think about it. Hey, you need to understand maths here. I think this should be 1.1, right? Yeah. So we need to say it's subset 1.1 because we're dealing with floats here. If I leave it as 1.0, right, it's gonna stop at 0.9, which is not the right range. So we need to say 1.1 so that it stops at exactly 1.0. If you get the maths. So this is a maths related thing. I don't have to teach you that. It's not a maths lecture. So you need to put in the F there because remember, if you leave it like this, Java treats this as a double. This next float function, it expects floats. So I need to put that suffix F there to tell it these are float constants or float values, not doubles. Yeah, if you try to do spiritual things like this, right? Agree, I said 1.1, and then you try to say no, but maybe shouldn't it be 2.0? Yeah, you're being very, very spiritual. Because now your range is gonna stop at 1.9, which is wrong, which is not answering the question at all. Then you start deducting marks. So yeah, I've initialized my acceleration index, right? That's done. Let's go back to our code, our PDF. Let's see. Print the amount. So now let's override the method. So it's photon amount divided by acceleration index. So that's the string I'm going to use and I'm printing the number. So I just multiply the two values. That's it. So I'm going to float. I'm going to say, call it multiply, right? It's just going to store the answer. So I'm going to call photon amount, right? Times, because the star or the asterisk means multiplication, times acceleration index. And remember what the processor, right? The CPU, as long as at least one of these is a float, it's going to cast the other one to a float. Or you can use the word promote. It's going to promote the other data type to a float. So yeah, so I'm gonna multiplied it. I'm done. Now I'm gonna print because it said this function should print. Then it's gonna take in the string literal and the variable. So I said multiply. So multiply, that's what I called it. You can call it something else. Then that's the string that's going to be displayed. So capitalize this. Photon multiplied by index is then again %f, but we need to round it off to 2 decimals, so .2f. Then we need to print a new line character once you're done. It's just %n. And then I'm done with the functions. So I've overridden all the functions. I've initialized my instance variables for my subclasses. That's sorted. And they said, if you look at this, they said you should print both on the standard output string. As you can see, I used the out, which represents standard output stream. If the standard error stream, it will be ERR. So in this case, I'm just gonna say standard out because I'm answering the question. Then let's see what's the other class we need to create. We need to create a collider container. So create this class, go here, go to my project source folder, new. Just, when you're creating a class, just be very careful. Select the folder, SRC folder before you create. Because if you select here, the class is going to be outside of any folder. You're just going to have problems with finding it. It's going to cause errors, which is going to lead to your code being kept at 40%. One small problem can affect can change the whole trajectory of the semester test. So I'm going to create a new class, right? And then name is collider container, generate comments because I need Java doc, and done. Then I'm going to copy my Java doc, this one, copy it and put it there, right? So there's the Java doc. Then I'm going to go back to my PDF. So it is an array list, right, of photon colliders. Collider container contains that operation, which is a function. We'll talk about we'll implement the operation later. So let's talk about array list. So it's an array list of photon colliders, right? So photon colliders. So they said photon colliders. So that means its type is going to be, what is going to make it private? So the type of each value in the array list is going to be of type photon collider, right? Then I'm going to call it, I'm going to say these are photons, right? And then these are my instance variables. In this case, we only have one, but you can usually have more than one. And then constructor, let's see if we need a constructor for that. We might not necessarily need it. If you think about it. Yeah, I don't think we need it. Yeah. Yeah, so let's start with the add collider. So we've done this part, right? Here's a array list. But okay, we need it. Let me create it. Because we need to instantiate the array list. Remember the array list, you see, it starts in the capital letter A, meaning it's a class. So we need to instantiate it, or else it's gonna give us an error. So collider container, even though it doesn't take any parameters, that's fine. Then I simply instantiate my photons array list. This goes to new array list. Remember, based on Java, what version? I forgot which version, but you can now omit the type here. You don't have to say photon collider here. You should usually put the photon collider only when you're declaring it, right? But when you're instantiating it like this, you don't need to put the type there. You could, right? Photon colliders. You could, but then that would be kind of making it complicated. But you could make it, you could use generics here. You can use generics in a fancy way. For example, you can make this a generic class by putting T there. Then you say that that type should be a type that extends photon collider. Because it's photon it's photon colliders, meaning that it's subclasses of photon. You could do that, but that's not what the question asks. So don't, that was just for demonstration. Then you're gonna need to create an add collider method. By operation, they mean a method or a function to add instances of photon collider to the array list. So I'm gonna create that function. It's simply adding, so it's basically a setter, right? So okay, I didn't copy the name. I thought I did. So copy the name because I'm that lazy. It needs to basically takes in one photon. Remember, this is an array list. It's a collection of photon. We should create a method that adds one photon collider at a time, right? So that means that I need to take in one photon collider. So photon collider is just one photon, right? Then I'm gonna add it to my array list of photons, right? So photons dot add. Remember, the array list is an add method. So photon dot add, and we're adding this specific photon that's going to be passed. And another thing about Java, right, that you need to understand, you might be like, well, wait, was I even doing Java the whole time? Let me double check something. I wasn't doing Java the right way. Yeah, I've been busy with C++, kind of got, it's 3 asterisks, right? It's not 2. So Photon, I don't have to put in comments on that, but I wanted to explain the parameters, right? The way Java works, right? If you create a function and you pass in the type of a reference type, Java allows you to sort of achieve some like polymorphism in a way, right? Basically, that means the function accepts a photon collider and any descendant of photon collider. That means you can call this method and pass in a basic collider. You can call this method and pass in an experimental collider. That's why I declared it this way. If you declared it in another way, for example, you said pass basic collider, you need to create another add collider for experimental collider. What if in the future you decided that there's not just 2 colliders, there's 16? That means you're gonna have 16 of these functions again, right? So that's unnecessary. You can just create one function, use your understanding of Java, of which, excuse me, of which your understanding of Java you can only know if you read the textbook. So yeah, all of this information that I'm telling you, I'm getting it from the textbook. I'm not some wizard or some prophet. I read the textbook. That I didn't like it, but it had to be done. You do it even if you don't want to. It's not a matter of making excuses. Operation to add instances of photon collider to the array list, we did that. And sometimes they kind of give you hints. The thing is, you guys are asleep. You can't even see hints when they're right in your face. They said operation to add to the array list. There's an add method. So that's, like I said, straightforward. You can do this thing in 2 minutes. Done. Then maybe the UMO can take like 10 minutes tops. Yeah, this is a very short question. The thing is, I'm explaining quite a lot, so that's why it's taking long. Audio should have been done a long time ago. The collider container also has test colliders, so I need to copy this. And they said it's an operation that will call, right? It will call that other function of each photon collider in the array list, right? So that means that function is going to be void because they didn't tell us about the returning, blah, blah, blah. So I don't have to worry about that. So void again. So public void test colliders. And they say it simply calls, so there's no parameters. It calls a method for, it calls the method for that abstract method, if you remember this one. It calls it for each photon. If you check the question here, for each photon, collide. Like I said, they're giving you hints again of each. You need to use a for each loop there. So I'm gonna say for each photon collider, I'm gonna call it photon again in the array list of photons, right? So I'm using it for each loop. And they said you need to call the report micro black hole function. So you need to call it. So it's simple. You call the method. So if you remember for each loop, we discussed it. So let me, okay, I'm feeling parched now. Let me drink some water. I think of talking a lot. Yeah, it's really annoying. I think my voice is starting to fade away bit by bit. So I need to call the photon of the report for each photon collider. So if you remember for each loop, right, it goes through that collection, which is that array list, right? And then it takes one by one, right? And then it stores it one by one inside this variable. And this type, we need to make sure it matches the type of the array list, which is the type over here, right? Because when you say this, right, you're saying this is a collection. Everything in that array list is of type photon collider. Then obviously this would be that each thing that you're getting there is of type photon collider because that's what the array list stores. If you cut me and you do your spiritual things and you say basic collider, you see error, that's your own problem. And this happens a lot if you cram. You'll notice, you'll see for yourself if you've crammed, you'll see for yourself when you enter that vein. You might even black out and not remember anything at all. So I'm gonna call that function done. That's all you have to do. Like I said, you can do this thing in 2 minutes, provided you're not teaching anyone, you're not explaining it to anyone. You know the code. So we're done with question 1. Now we just left our main, then we'll be officially done. So let's do our main. Okay, I think we should do UML only this once, right? Like I said, only this once. This paper, right, we're gonna do a lot of explanation of things and a lot of UML if there's UML and things like that. But then every paper that follows, you go do it on your own. As long as I demonstrate it once, that's all that matters. Because it's gonna take a lot of time. Imagine trying to draw those diagrams and then I'm taking there and then I'm trying to drag, it doesn't drag. You see, time. Session end up becoming 1 hour just answering question 2 or just doing UML. We haven't even gone to question 2. So you need to make sure you read all the instructions, right? To be honest, let me check. Did they mention that you should use good OOP, not what I taught to you? They didn't put that statement, didn't they? Yeah, they didn't put it. Yeah, since they didn't put it, let me see, has a relationship. Yeah, you have that is there, it's there. You make it abstract, blah blah, it's there. Overrides, yeah. So as you can see, there's no marks for accessors and mutators, right? Don't put them. Waste of time. You can put them if you want to show off and you're done with everything, right? Every question you've answered within an hour. You have a lot of time on your hands. You can put all the accessors and mutators you want, but there's no marks for it. Just know that. In the Java program, create a main class. Main class, they mean the class itself is going to be called main. It's always called main, so you don't have to think about it. It's not rocket science. It's always going to be called main, especially in Java. So you see, there's the class it's called main. If you called yourself, I don't know, superhero, what, marks gone. That's how students fail to get 100 because simply failing to follow instructions. Naming of things is very important. There's marks for that. The main class must instantiate a collider container. Yeah, so they said it should instantiate a collider container, right? So that's a collider container. So I'm going to do that. So let me instantiate that. So let me copy the name. I'm gonna call it container. Yeah, we'll just call it contain. So collider container. They said instantiate it. So call the constructors, goes to new collider container. And then done, right? We've instantiated it. Step 1 is done. And they said fill it in with 10 random instances of photon collider. So there should be 10 random instances. Basically, you should randomly create a basic collider or an experimental collider based on some notation. But they said 10 random instances. If you know for loops, this is where you know you should use a for loop because you're counting to 10 and you know an exact number. So from 0, I is less than 10, I plus plus, because I know what the code I'm about to write, I must repeat it 10 times because I need to create 10 instances. Then I go back here, I'm going to check the question. To determine which instance of photon collider to instantiate, create a random integer. They said a random integer, they didn't tell you which range. So you're going to call the next int function or method that takes no parameters. So I need to instantiate my random instance first. So random is equals to new, random, right, import. And we need to do this thing 10 times, right? So we need to keep on generating the random number. And then we check, is it even? If it's even, make a basic collider. If it's odd, make an experimental collider. So we need to do this continuously, right? So the part whereby you generate the random integer should be placed within the loop. The instantiation part, right, this part, it can be done once because you need to instantiate the object once. Don't be putting it inside the for loop. That's what makes your code slow. In ComSci 3A, they'll teach you how to make your code fast. And you can understand that certain things need to be avoided in order to improve the speed of your application. So yeah, because computers, they can take even 3 billion years just running. If you press this run button, right, it's going to take 3 billion years before it shows you output. There's things like that in ComSci. So that's why they're very specific. You need to be very alert, right? Avoid things that need to be avoided. So let's create the random integer, right? So I'm going to declare the variable outside because declaration kind of takes time. So I'll make sure I do it outside. I'll call this number, initialize it to 0. Then inside the loop, I'm going to change it to some random integer. So it's equals to rand.nextInt. Remember, they didn't specify whether it's with the range, the upper bound and the lower bound. They didn't give you. So you just pass this one with no bounds because they didn't say it should be within this bounds. Then we need to check, right? You need to check if it's a. I'm thinking about cooking something here. I'm thinking about using a ternary operator. Yeah, let me cook something. Let me use a ternary operator. It's gonna be ugly. It's gonna be very ugly, but yeah, it needs you to really sit down and think about it. But I'll show you two ways. So if the integer is even, create a basic collider. So it's simple. How do you know a number is even? Maths. If you didn't know, go and revise. So 2k plus 1, where k is an element of z. Still remember, this is what represents an odd number. It means that an odd number is a remainder of 1. An even number is no remainder if it's divided by 2. Simple. So I'm going to say if number, what operator, arithmetic operator do we use in Java if we want to find a remainder? It's the percent symbol or the modulus symbol. So a number divided by 2, if after dividing by 2, you get back a 1, that means it's odd. If you get back a 0, that means it's even. And you can either get one of these numbers, 0 or 1. So that's why I'm going to do my if statement like this. I'm going to have an if and an else. Because an else, it means that I'm using an if else because I know for a fact it's going to be one of these numbers, either 0 or a 1. Then if it's a 0, then it's even, right? This is even, and then this is when it's odd, right? Like I said, I can use a ternary operator for this. So okay, your job, right? Your another homework. You need to find a way to remove my ternary operator and convert it to this if statement. Only if it's confusing for you. But this is the way to do it with an if statement. I actually just showed you the answer, but you see some people still get confused. So I have this, so I'm gonna have if the integer is even, then create a basic collider. If it's odd, then create an experimental collider. Remember all these child classes, right? They have parameterless constructors. So I don't have to worry about parameters. I just simply say new. That's it. Followed by the name of the class that I want to instantiate. And if you remember collider container, we just finished creating a function to add the collider. It's called add collider, which takes in a photon collider. And I did mention that functions, even if you pass in the data type of the base class, you can still accept the child classes. Why? Because all the child classes are photon colliders, right? They are photon colliders. So that's why you should accept them. So now I'm going to say container, right? Go to my collider container, call the add collider method, right? Remember the ternary operator, it returns, you can make it, it's used when you want to return something of some type. In this case, I'm going to use it in a stylish way. So I'm going to say if number modulus 2 is equals to 0, right? Question mark. That means that we're asking that question. When it's true, meaning that the number is even, we should create a basic collider. So I'm going to say new basic collider, right? And then when it's false, we create a new experimental collider. So new experimental collider, right? Yeah, perfect. And my code is going to run because, like I said, I understand Java. I read the textbook. If you don't read the textbook, you always know one way, which is a problem because you're gonna meet people like me who are going to utilize the understanding of Java to its full extent. You see, I use Java. It's work. This is perfect. It works because if you remember what I talked about ternary operators, right? When it's true, you return some value. In this case, we are returning an instance of that thing, right? And it's going to be passed into add collider. And then you're done. You've created the colliders based on some random number. And do you see how short this thing is? Is one line. So you need to kind of understand the different techniques, right? So we're gonna do this 10 times since it's inside the for loop, or that counts 10 times. So that means we're gonna have 10 random colliders because that's gonna be repeated 10 times. We're gonna add the colliders, those random colliders 10 times. So yeah. Then I'm gonna go to my code, to my PDF, then we're gonna check here, right? So after the container is filled, meaning after the loop is done, that's basically what they're telling you. Call the test colliders method. Remember the test colliders method, right? It calls the report black hole method. Then for each collider. So I'm gonna say container dot test colliders. And then done. That's everything. You should get 100% once you're done here. Bam, there's the output. So that's how simple this question one was. Question one is usually 3 marks. That's how I've seen it now. It's usually 3 marks. Um, nope. Come on. Just give me a sec. I want to set this thing. Yeah. So let me do this. Yeah, so there's the output, right? Photon amount divided by 10 is this. And you see that they are random, right? I have a photon here, I have that. But then the thing is, okay, they're random, it's fine, but you could have said it's up to you. Your string could be the output of, you specify what's the photon, what type of photon it is, basic collider or experimental collider. You could have done that. That's up to you. Then you can just simply clear the console by pressing that, delete everything. Then let me see if I can't pin it to this side. Okay, it's fine. I'll just leave it. Yeah, so that's basically what they wanted you guys to do. So that's the 4 marks. So let's see, is the relationship correct inheritance, right? Extends. Basically, they're gonna mark the extends keyword. Then overrides. The 3 marks for overrides, right? You only get it if you have the annotation at override. If it's not there, you're not going to get the full 3 marks. Like I said, students, they fail to get total because of failure to follow instructions. That's all. You might know the code, but if you fail to follow instructions and name things the way they want you to name them, you're going to have issues. So here, there's the main class. You're going to get full marks again. You see, you called the test. You see that one line for calling, there's 1 mark for that. For filling, that for loop for filling, it has 6 marks. And then to instantiate, that first part is 1 mark again. So this is 1 mark over here. This part of here is 6 marks. This is 1 mark. So you can't fail to get those marks. Like I said, question 1 should be an easy peasy for you. Maybe question 2, still question 2 is easy. To be honest, you should get 100 here. I don't see why you'd fail to get 100 because there's no Java FX. As we were told, we were forced to do Java FX even if we didn't like it. It was there in the paper. You know you're gonna meet it. So lucky for you guys, they're actually going way easy on you. You guys are also supposed to have a practical whereby you make a game using Java FX. So you see, this is just an image. You must make this image move like a player. That's if your game is based on a soccer game. And it must also have audio, like you can put audio maybe or some a score somewhere there by the corner. 1-0, if you scored 2-0, if it's a draw, all those things. And you can also record yourself, put an audio to record that every time it hits the goalpost, it's gonna say goal, something like that. You can put that recording in there. It went down. You guys doing Java now when it's easy. So I don't see why you guys I'm making a big fuss out of it. This is easy, way easier than first year. If we were to take some of you guys to first year right now, hey, nah, you'd have to be adding an extra year after plus that year we're taking you back because some of you are gonna have to repeat that module because now Dr. Stung is making the practicals hard. He has no time for jokes. If you see the practicals, hey, it's going down there. So we'll do question 2 tomorrow. Then on the other days we'll do the day after tomorrow we'll do the other question paper. But then we'll start with I hope we have time. If we don't have time, we'll see. I want to cover the UMO diagram. So I'm gonna start with that. It should be quick. The thing is, the annoying part is the packaging. You see the packaging. Yeah, that's the annoying part. Lucky enough with this practical, right? There was no packaging. But most of the time, they're gonna want you to do packaging. I think for the latest papers, right? Let me check 2022. For the latest papers, they're gonna do packaging. So I think we can skip for 2020 paper. We won't do packaging, the UML for that paper. You go do it. We'll do the did I do the UML here? I didn't. Yeah. So I can just do the UML for this one. Right, yeah. We can just do UML. Did they mention? No, they don't. Oh, they did, yeah. There is it's hidden. It's right there. You see this one? It's not there. They didn't mention the packages. So you're gonna slide on this. You're gonna get away with it in this question because they were letting it slide here. They're like, it's cool. You don't have to worry about packaging because if you're worried about packaging, do I still have Dia installed here? I don't have it. Yeah, I need to download it. Yeah, inside Dia, agree, there's option whereby you can place your classes inside packages and stuff. You'd have to do that, give it the right name and everything, which is really annoying. And it becomes, your diagrams become big, especially with a lot of multiple classes. They end up becoming big. So yeah, that's it for today. And yeah, we're done. Oh yeah, I just remember something. They gave you a hint here. You said this next float. Yeah, I totally forgot about that. Yeah, I read about it a long time ago. If you remember when you're generating a float here, let's go back here. You see here in generating a float, to be honest, you can actually omit it like this because by default, when it's not parameterized, it returns a random value or random float between 0 and 1. So you don't have to necessarily pass the parameters there, but at least I showed you how you do it if you wanted to pass the parameters. I need to do that thing again. Just give me a sec. Okay, there we go. And I'm gonna enlarge this. We just need to double check it. Let's see. Thing is, I'm almost. Oh, the thing is, we're not sure because it multiplies them. Yeah, we're not sure. Yeah, it multiplies them, but just know it actually generates it between 0 and 1. You can even check the Java doc to confirm it is there. I know, I just remembered it now. I'd forgotten, but yeah, it generates a number between 0 and 1. Even in C++, we call a random function. Yeah, it's also the same in C++. So what are we looking for again? Next, load in random class Java doc. Yeah, so this is the random class. I could have just said random class Java doc, that's fine. So I'm gonna scroll down. I need the next float, right? Yeah, you see the documentation. It returns the next pseudo random, meaning it's somewhat random. It mimics a random, but not actually random, between 0.0 and 1.0. So by default, if it's not parameterized, it returns within that range. I think they're also testing whether you also treat documentation. Then for Gaussian, what this is for people who do linear, yeah, I think, yeah, linear, it should be there. Even stats, the Gaussian function that you should relate if you're doing stats and com sci. So yeah, this is the documentation. You can search all the functions you need there. So yeah, let me end the session now. So that's it for today's session. We'll continue question 2 tomorrow. Hope you guys have a lovely evening.